Hello everyone, this is Siddiqur Rahman and welcome to the first lecture of the 5th week. So let's start. By the end of the lecture, you guys will able to know or you guys will able to describe about encoder. From this slide, we may know about the outline of this lecture. We may learn from this lecture such as overview of encoder, overview of transducer and its classification, overview of 422 encoder, or you can say how to design 422 encoder. After this, we can learn priority encoder, and we can also learn how to design 422 or 4 inputs priority encoder and some other topics. So let's move to the next slide. In digital electronic projects, the encoder plays an important role. It is used to convert the data from one form to another form. Generally, this is frequently used in the communication system like telecommunication, networking, and transfer the data from one end to the other end. In the same way, it is also used in the digital domain for easy transmission of data, placed with the codes and then transmitted. At the end of the receiver, the coded data are collected from the code and then processed to display. From this slide, we may learn or we can learn the overview of encoder. So let's begin. An encoder is a combinational circuit that performs the reverse operation of decoder. It has maximum of 2 to the power n input lines and n output lines. It will produce a binary code equivalent to the input, which is active high. Therefore, the encoder encodes 2 to the power n input lines with n bits. It is optional to represent the enable signal in encoders. In short and other words, we can say an encoder is a circuit that changes a set of signals into a code. The encoder is a device or a transducer or a circuit. The encoder will convert the information from one format to another format, such as or which means like electrical signals to counters, or a programmable logic counter, which is in short PLC. The feedback signal of the encoder will determine the position, count, speed, and direction. The control devices are used to send the command to a particular function. From this slide, we see or we notice that there is a figure which is represent the concept of encoder, which we have already learned from the previous slide. And if you see this figure, then you can find in the left side there are 2 to the power n number of inputs, and in the right side there are n number of outputs. So let's move into the next slide. Now a question may arise from the previous slide, that what is transducer? So let's start with the transducer. An electrical transducer is a device which is capable of converting physical quantities into a proportional electrical quantity such as voltage or electric current. Hence, it converts any quantity to be measured into a usable electrical signal. This physical quantity which is to be measured can be pressure, level, temperature, displacement, etc. The output which is obtained from the transducer is in the electrical form and is equivalent to the measured quantity. For example, a temperature transducer will convert temperature to an equivalent electrical potential. This output signal can be used to control the physical quantity or display it. From this slide, we may learn or we may observe what is the classification or types of transducer. What is the classification of transducer, or you can say types of transducer? So let's start. There are of many different types of transducer. They can be classified based on various criteria, such as number one, based on quantity to be measured, which is number one is temperature transducers, as for example thermocouple, pressure transducers such as diaphragm, displacement transducers such as linear variable displacement transducer, which is in short LVDT. Next one, oscillator transducer, flow transducers, inductive transducers. Now another criteria or another type of criteria which is based on principle of operation. Number one, photovoltaic such as solar cell. Next one, piezoelectric transducer. Next one, chemical. Next one, mutual induction. Next one, electromagnetic. Next, Hall effect. And last one is photoconductors. Now from this slide we may learn the overview of 422 encoder, or you can say how to design 422 encoder. So let's start with the first step. First step should be inputs and outputs declaration. Let 422 encoder has 4 inputs, and before going to describe, I must say an important thing for you guys. What is 422 encoder? Just observe from the name. 4 represents the number of inputs and 2 represents the number of outputs. So 422 encoder means this encoder has 4 number of inputs, or the number of inputs of this encoder is 4, and the output of this encoder should be 2. So let's start with the first step. Let 422 encoder has 4 inputs, which is symbolized by Y3, Y2, Y1 and Y0, and 2 outputs which is also symbolized by A1 and A0. Second step should be draw the block diagram of this encoder. The block diagram of 422 encoder is shown in below. And another important information we have to remember for our design, which is at any time only one of these 4 inputs can be 1 in order to get the respective binary code at the output, which means since this encoder has 4 inputs and at one time or at any time only one input should be activated out of the 4, not all of the input. Just remember these things well. And figure 2 represents block diagram of 422 encoder, which has 4 inputs, which we have already known from the above paragraph, and also this encoder has 2 output, which also we have which also known from the above paragraph. So let's move into the next slide. Third step should be truth table of 422 encoder. So the truth table of 422 encoder is shown in below, and we already mentioned in the previous slide that since this encoder has 4 inputs, so at one time or at any time only one input should be active. So that's why from for the input section you may find y0 or y0, y1, y2, y3, and each time only one input only activated. That's why we place just one, which means high. So first row represent 1 0 0 0. Since y0 already activated, so that's why the next stage or next step y0 is not activated. After y0 we get y1, which should be activated in the second step. So that's why second row or third row you can say 0 1 0 0, and in this way the rest of the cases, which is 0 0 1 0 and 0 0 0 1. And in the output section, we already know this encoder has only two output, and for two output we can assign two binary number, which means one is 0 and another one is 1. And if we combine these two numbers, then we get four combination, which is 0 0 0 1 1 0 and 1 1. So let's move into the next slide. Now fourth step should be Boolean functions of each outputs of 422 encoder. From the truth table below, or you can say in the from previous slide, we can write the Boolean expression or Boolean function for each output. Since this encoder has only two output, that's why we get two Boolean function or Boolean equation. So for the first output, which is A1 or you can say A0, if we look at the truth table, then we can find for the A0 or A0 output we get only 2 1, or we get only 2 1 for the two condition. One is for y1 and another one is for y3. That's why we can write A0 or A0 is equals to y3 or y1. Just think about this in this way. Similarly, for A1, which is for this output or for the second output, we also get 2 1 for the two condition. One is for y2 and another one is for y3. So we can write A1 is equals to y3 or y2. Fifth step would be the implementation of the logic circuit of 422 encoder. Since we got two Boolean functions for two outputs, so we can implement the two Boolean functions by using two input OR gates. The circuit diagram of 422 encoder is shown in below, and we already know we get two equations for the two output. One is A0 is equals to y3 or y1, and another one is A1 is equals to y3 or y2. That's why we only need two OR gate, since the positive operator is equivalent to OR. That's why we represent in this I repeat again, for this reason we represent this encoder by using OR gate. And also remember one thing, this OR gate has two inputs only. So figure 3 represent logic circuit diagram of 422 encoder. So let's move into the next slide. From this slide we may learn the overview of priority encoder. So let's start. A priority encoder is one of the types of encoders in which an ordering is imposed to the inputs, that means compared with the standard encoder. It includes the priority function. However, this priority is based on the relative magnitudes of the inputs. Hence, the input with larger magnitude is the one that is encoded first. Priority encoders can select the inputs with highest priority. In many practical applications, this sorry, I repeat again, in many practical applications, this process of selection is called arbitration. One of the most common example of arbitration is that there are numerous input devices in computer system, and several of which devices attempt to supply the data to the computer simultaneously. In those cases, a priority encoder enables the input device having the highest priority among those devices trying to access the computer at the same time. Now, from this slide, we can learn an overview of 422 priority encoder. So let's start. This priority encoder consists of 4 inputs and 3 outputs. One confusion may arise in your mind. We already know from the previous lecture or previous slide that 422 encoder which means 4 represents the number of inputs and 2 represents the number of outputs. You are absolutely correct, but priority encoder has different scenario, so we don't create any confusion about this matter. So that's why we are clearing at these facts at the first of this overview. So let's start. This priority, I repeat it again, this priority encoder consists of 4 inputs and 3 outputs. Although an encoder has 2 to the power n inputs and n outputs, it has third output which is symbolized by A0 and which is also known as valid bit indicator and is set to 1 when 1 or more inputs are active or equal to 1. Remember these things. I repeat it again. A0, which is known as valid bit indicator and is set to 1 when 1 or more inputs are active or equal to 1. This valid bit is 0 when all the inputs are 0, which indicates that there is no valid input. On this condition, other outputs are considered as don't care conditions and are not inspected when A0 or A base 0 is 0. The highest will be the priority of the input with a higher subscript number according to the truth table, that is most significant bit will have highest priority while the least significant bit, sorry I repeat again, significant bit will have low priority. Now come to the design of 422 priority encoder. So let's start with the first step. First step should be we have already known from that 422 encoder, so we don't need to worry about this matter. So let's start. First step should be inputs and outputs declaration. Let's 422 priority encoder, also known as 4 inputs priority encoder, which has 4 inputs, which is symbolized also by Y0, Y1, Y2 and Y3, and we have already known that this type of encoder has 3 outputs, which is symbolized by A0, A1 and A2. So let's move into the next step. From this slide we may learn the second step of this encoder, which is priority encoder, and second step should be draw the block diagram. The block diagram of 422 or 4 inputs priority encoder is shown in below, and which is represented by figure 4, and we have already seen from the figure that there are 4 inputs and is symbolized by Y0, Y1, Y2 and Y3, and Y0 is the lowest priority and Y3 is the highest priority. Remember these things. And in the right side of this figure we may find 3 outputs, which is symbolized by A0, A1 and A2. And another important thing you have to remember for this type of encoder, which is at any time only one of these 4 inputs can be 1 in order to get the respective binary code at the output. So third step should be the truth table of 4 to 2 or 4 input priority encoder. The truth table of 4 to 2 or 4 to 4 inputs priority encoder is shown is represented in here, and first row you can see there are no active input. That's why in the output section A2 and A1, the condition of the output section and you can say, or we can say, A1 and A2 should be in don't care condition, and that's why the third output, which is detected the valid bit detector and represents is 0. After this row we may find y0 is active, which means the value of y0 input is 1 and the rest of the inputs are 0. In that case the bit indicator is 1, and the output section, which is the output section A1 and A2, for this section we assign 2 individual binary numbers. One is 0 and another one is 1. We have already know that about this matter, and if we combine these 2 numbers, after that we get 4 combination, which is 0 0 0 1 1 0 and 1 1. And third row, when the third row means which means when y0 is 1, after that, after the next step, y1 should be 1. After this y2 should be 1, and after this y3 should be 1. But when y1 is equivalent to, or it is equals to 1, when on that case y0 should be don't care condition. This is the requirement for this encoder. So let's move into the next slide. Now in the truth table, y3 has the highest priority. We have already mentioned in the block diagram, so we don't need any worry about this matter. And y0 has the lowest priority. Well, when y3 is active or 1, then regardless of other inputs, okay, the output is 1 1. We have already seen from the truth table, so we don't have any confusion or any worries about this matter. The next higher priority is y2 after y3. We have already seen from the truth table y3, then y2, then thus y3 is 0, then y2 is 1, then regardless of other 2 inputs which has lower priority, the output is 1 and 0. When higher priority inputs are 0, then the output for y1 is generated, and so on down the priority levels. Down the priority levels means y3, y2, y1, y0, in this way. So let's move into the next slide. Fourth step should be the Boolean function of this encoder. So let's start. Boolean functions of each outputs of 4 to 2 or 4 inputs priority encoder. From the truth table below, we can write the Boolean function for each output as follows. One is A1 and another one is A2. A1 should be Y3 or not Y2 and Y1. And A2 is equals to Y3 or Y2. If you see from the if you see at the truth table, then you don't have any confusion regarding to find the Boolean function of this encoder. So let's move into the next slide. Fifth step should be the implementation of this encoder. Okay, since we got two Boolean functions for two outputs. So we can implement the two Boolean functions by using two input OR gate, one 4 input OR gate, and one 2 input AND gate, and last one is one NOT gate. And we have already seen this type of gates, which is represented by figure number 4, so we don't have any confusion. So let's move into the next slide. From this slide we may learn the applications of encoder. So let's start. There are several applications of encoders, such as encoders are very common electric circuits which is used in all digital systems. Next one, encoders are used to translate the decimal values to the binary in order to perform the binary functions such as addition, subtraction, multiplication, etc. Last one, other applications especially for priority encoders may include detecting interrupts in microprocessor applications. From this slide we may learn some of the drawbacks of the encoders, such as there is an ambiguity when all outputs of encoder are equal to 0, and last one is if more than one input is active high, then the encoder produces an output which may not be the correct code. I hope you guys will understand the last drawbacks. In the next lecture, you guys will learn about the decoder. And that's all for this lecture. Thank you guys for your attention. See you guys in the next lecture. Thank you.